Hello and welcome to another video. Today we have something quite different on our bench. It's still an AM4 socket, but it's an actual Biostar board. I get to work on Biostar boards very rarely. Like I think there's one Biostar video on this channel before where it was an Intel socket, but I don't think I've ever worked on a Biostar AM4 CPU or mainboard before. And this came to me with an unknown fault. Only description that I had is that there's a component missing. And the component in question is that MOSFET right there at the top. So someone had desoldered a MOSFET from here, which leads me to believe that this had a shorted VRM section. But we will start, like usual on the spot, with checking resistances. So let's see for the 24-pin connector. We start at the bottom right, and we have kilo ohms. Then fourth pin from the top, 5 VSB, also kilo ohms, 12 volts, kilo ohms, 5 volts, kilo ohms. Okay, let's then check the 12 volts to ground, and it has a short circuit. The 12 volts from the CPU to ground is shorted. So there is a VRM short that they have been searching for, and the big question is, what is it actually? Let's then go under the microscope and inspect the area that they have been soldering at, if we can see anything there already. So it looks like the PWM controller also has been soldered at, which is bad because these PWM controllers, they have software in them that is important. Very interesting. Looks like basically all of these phases have been worked at. Like with all of these solder everywhere, it feels like all of these had been worked at. Like someone was really trying to fight a short circuit here, wasn't they? This is a mess. Holy moly. This will be quite the interesting repair, I think. Or rabbit hole. One of the big problems is that these PWM controllers, they have firmware on them that is not public. And if you don't have a donor board, you won't be able to fix it. Was this also soldered? Interesting. Like, what has not been touched on this board? That's crazy how much work there has been done. Well, we will give this a fair shot. This might end up in just us not fixing it, because they're like, everything of here has been worked on. And yeah, even some traces damaged here, as you can see. This is probably just some USB thing. Yeah, it is USB, so not that important. But still. Someone has really tried to get this fixed, but obviously gave up at some point. And couldn't even find the main issue, which is a shorted MOSFET anywhere, somewhere. Even more damage here. Like, that one trace is, I think, completely blown through. Or is that... No, that is just whatever this is. Red stuff here. This looks like insulation for, like, people use that for doing, like, liquid nitrogen overclocks and stuff. That looks like that stuff. Oh yeah, these capacitors were resoldered also. Someone struggled heavily with those. Oh yeah. Damn, this board has seen some better days. This will be quite the journey to fix. I can already see that. Well, we're going to start with injecting voltage into here in order to see what is shorted. In order to find out probably that one of these MOSFETs is still shorted. So let me build up our voltage injection system. So let's see right here. How much will this take when injecting voltage? 160 milliamps at 1 volts. Let's see if the thermal camera... Yeah, there's something here. And that is a doubler, I think. or not a doubler, it is a PWM controller, not the... This is a MOSFET driver, now I got it. Searching for the right word for it. The MOSFET driver here seems to be shorted here, because it takes the power at 1 volt, it already takes 130 milliamps. Yeah, and that MOSFET driver seems to be dead. So let's remove that MOSFET driver. Let's get rid of the capacitor that is close to it. Let's do that under the microscope so you can see better what I'm doing here. First, let me quickly get that capacitor out, and then we will get that MOSFET driver out. So let's quickly remove the cap right here, that we can work better in that area. So the cap is out. Let's now go under the microscope and have a good look at that component. And this was the one that seemed to be shorted. So it might actually be the soldering, but it might be the component as well. So let's just take it off and see if the short disappears on the 12 volt line. We do not know what kind of solder has been used here, but let's blast this off. So chip is out. I don't even think I need to clean any of the solder here, but I'm still going to go over it a little bit, because I think it removed cleanly. Let's then check for the resistance again. So in the 24-pin connector, let's check the resistance to ground. And now we have kilo ohms. Okay, yeah, as you can see. So that was that problem. Let's see now if there might be a fault with the 12 volts being shorted into a phase. And yeah, we also do have 12 volts short into the phase. Great. Okay, so there's also a shorted MOSFET then. So what I like to do for that, so this is where we actually check from the 12 volts to here, and we see the 0 ohms. What I like to do then is I like to take a wire. So let's solder a wire to here, to this output. And now having solder on here, let's put the wire on here. And now what we are going to do, we're going to connect the ground clamp to that. And we're going to be injecting voltage into the 12 volts right there. And then we're going to see if what gets hot then. So thermal camera is connected once more. Let's now see how much this will take now. So I'm not getting any current consumption right now. Something's weird. Yeah, I got something not attached. There it is. Now I get some amps. Just some of the connection weren't correctly. So I currently have 1 amp of power consumption. Let me raise that up a little bit. So we have a little bit more amps. 2 amps at almost a volt. Cannot see any specific heat build up on one of the MOSFETs. So with 2 amps of power consumption, I currently cannot see a big build-up of heat on any of the MOSFETs. I see a little bit of heat like behind the connector. I don't hope that anything under the connector was like botched, and that's why there's a short there now. Let's raise it a little bit more. So we're now at 5 amps. This should properly heat up if this is a shorted MOSFET. And it might be that one. That MOSFET is heating up, and that is probably our culprit. Yep. Because this is like what normal MOSFETs here look like. And this is the one that heats up. It is that middle one, yeah. Let's remove that one and then see again. So let's see, it was that MOSFET right there, SM4377. I've never seen this MOSFET before. Interesting. And it was definitely already soldered too. So yeah, this is the one that is shorting here. So let's desolder that. Put some flux onto here, because I have no idea if there's anything, any flux left or anything. Okay, this doesn't seem to be leaded solder, because this takes quite some time to remove. Yep. So the MOSFET is removed. Let's then now check if we still have shorts. So let's see, from the 12 volts. And now we have kilo ohms. 12 volts to the phase is now not shorted anymore. That is great to see. Okay, let's see for that MOSFET then. You should be able to like read a short on it. So let's see, from this to this. Yep, there we are. Short circuit. There we can see drain to source is less than 0 ohms. This was a very shorted MOSFET. So interesting that the person that was working on this before actually like soldered these MOSFETs, but didn't realize that one of them was actually shorted. Like that they couldn't find the issue with this. So with not having any short circuits anymore, let's remove these then. So we now seem to have no short circuits anymore. Let's confirm that once more together. So we had a short circuit from 12 volts to ground, which is right these two, which we now have kilo ohms. And now from the 12 volts to the CPU phase, we now also have high resistance. No more short circuits. That is very good. So we had one shorted controller and one shorted MOSFET on here. And the question now is, I don't know what that controller is for. It's probably, like I said, a MOSFET driver. But I want to see how this board would react if we would now actually try to put some power into here. I want to see how what the passive power consumption now is. And yeah, go from there. Because it might actually be that this already fixes the problem. Because this AM4 very often can start with less phases in startup for startup. And just the other phases have to work harder then. And we will figure this out now, because this was obviously the area that they have been working in, the VRM area, and they weren't able to find both of these short circuits. So first the one to ground and one to the phase. But we were able to do that. So let's put in power, and let's see what the power consumption of our 5 VSB will be. Actually, 80 milliamps. That looks very fine. Let's check for some voltages, because without a CPU, I would expect something around that. So let's see, 3 VSB present, just like it should be. Let's see, can I find like the 1.8 and similar things? Let's check some capacitors. No, I cannot see anything here. Let's see, can I find... Oh, yeah, 1.8 volts on the BIOS chip. That is good also. So I think we're just going to go with the CPU on here. Another 3.3 volts. I don't know where the 5 volt dual is supposed to be on this one. There probably, yeah, top right, 5 volt dual. Okay, yeah, I do not see any problem in turning this on or trying with the CPU currently. So 2200G in here, 130 milliamps. That's a little bit higher than I would like to. But I also cannot see where like the VDDP, for example, would be. But like 130 milliamps might also be fine on this. I think the VDDP is supposed to be somewhere down here. Let me see. Was this? No, 3.3 volts. Let me see if I can find the 0.9 volts, 105 volts. Okay, no, I cannot find the 0.9 volts, and I haven't had a look if I can find a like board view for this. Only 1.8 volts. Oh, there it is. 0.9 volts. VDDP was able to find it right here. There are these two controllers right there. and the upper one carries 1.8 volts, and the lower one carries the VDDP. Okay, so let's then try to turn this board on and see what will happen. If anything will blow up. 2.3 amps, that is a very good sign. Yeah, 2.3 amps, because we do not have any DRAM. That is looking very good so far. So, I'm going to go so far, and we're going to try this with the missing phases. And the missing phase controller. Because this seems to work. Let's see, this does have a TPM header. I've not tried this on a Biostar board before. If these postcards get postcodes out of these sockets here. This will be interesting to find out. If we can get any postcodes from here. So, let's try this then. Post screen is enabled. So, let's turn this on. We do get actually postcodes running on there. Let's see if the V-core survives long enough for us to get a post screen. 1.9 amps. No, I don't. I think we get a CPU V-core fault because of the missing phase. That might be the case because the controller is also not there. Let's see again. Let's try this once more. Because this, you see 2.6 amps. And I think it will go to the 1.9 with like, oh, it restarted. 2.6. 2.8, 2.9. Do we get a post screen? This is running quite long without the CPU phase. 3 amps. CPU must be getting really hot. Let me get a cooler onto here. Because the CPU is probably way too hot already. It might be boot looping. We might need to flash the BIOS on here. 2.1 amps. Is this boot board on? Because we do not get a picture. But do we get an indication? No, no indication on the USB keyboard. Let's test a different processor in here. Because the board seems to want to boot here. But something is still not working. Because I'm not too sure if the CPU phases will actually be the problem here. Because like I said, I've seen boards boot with quite some phases removed and quite some power missing. Because just the other ones will probably have to work harder then. Let's go over to a dedicated GPU with the 3100 in here and see if that will work better. So the postcodes don't really help. So I remove that. 4.3 amps, that looks very promising. 3.3 amps, 4.4 amps. And there's a post screen. There's a BIOS screen. Very great to see. So we have probably 2 missing phases here. But the board still boots. Let's get an actual, that is the splash screen. Let's see. Does it go any further than that? What does it say there? Do I need to press anything in order for us to enter an actual BIOS right here? Oh, is this? There is. Press delete to enter BIOS setup. And there's the Biostar utility. And working. Very good. Let's turn this off. So the 2200G is probably not supported by this board. But the board works and turns on right now. So whoever worked on this previously, all they had to find was the shorted MOSFET and that one shorted controller, that MOSFET driver, in order to get this board to boot. So far it looks like that our PWM controller works, which is was one of my biggest concerns for this board. And I'm very happy that that seems to be working. We now have to find out how to rebuild these CPU phases. So, I don't think I do have these MOSFETs anywhere. I will have a look, and I want to find out if I can find a board view to find out what that controller is that we have taken off. So, you could see that probably these two phases weren't working, just like the capacitor isn't there, the controller isn't there, and these two MOSFETs. And still the board turned on and was working. Like, I wouldn't stress test it. Like, I wouldn't run anything big on it. But just booting and getting into BIOS, that does definitely work. And we do have some little more things then also to take care of, like that those ripped traces may probably there. But let me see if I can find a board view for this in order for us to find out what components we need there. So I was actually able to find a schematic for an A320MH. This is basically the same board, just with a different chipset as far as it seems. And this is now the V-Core VRM. We have the PWM controller right here on this side. And then going one further, we can actually see a phase. And we can see those MOSFETs, SM4377N and SM4364N. These are the MOSFETs that are used in the configuration that we also have on the A520. And there's also this right here, an ISL chip, which is a MOSFET driver as far as I know. An ISL62A08BCRZ. And this is the example, pretty sure that is the package, DFN8. And this takes ground, VCC, a PWM signal, a boot, FFCM. This is probably the input voltage, then the upper gate, lower gate, and the phase. Yeah, and this is then controlling MOSFETs. Yup. And it creates APU VDD run. So this is a MOSFET driver that takes a input PWM Y from here somewhere there, PWM Y, takes that in and then sends that to a U gate and the lower gate for these MOSFETs right here. And this is supposed to be multiple times here. As you can see, there's another one, another controller, more MOSFETs, and these I think are directly controlled, as you can see. Phase L gate. So some do go directly to MOSFETs and some go to the MOSFET drivers first in order to work. And this is probably something else. So yeah, this is more memory power setup. So this is all that we have. How many phases is this? 1, 2, 3, 4, 5. So this is like a 5-phase setup. And we have a little bit more, I think, on our setup. We have a 6. No, this might even be a 7-phase setup that we have here on this board. So yeah, but it is pretty similar. The big question now is, do I have one of these MOSFETs and do I have one of these controllers? So I will have to go into my stash and see for donor boards, because I definitely don't have Biostar boards, but the question is, does anyone else carry any of these parts? So I've actually found something similar for the MOSFETs on a Z390 board. I found SM4337 and SM4503s, and we have SM4377 and SM4364N. So I might be able to replace those with each other, but I'm still searching for that ISL controller. So the only place where I was able to find that ISL MOSFET driver is actually another Biostar board that I wanted to fix. But we will get this one off of here in order to test the one that we have currently, just to make sure that all of the phases can work fine and that there's no additional damage. So what we will do, we will take this off of here, but we will return it later. And I will then order some, because I do not have these except this single one, or this one, or the ones on this board right here. And yeah, like I said, this was the next board in queue that I actually wanted to fix. So this will just be temporarily off of here for me to take, so that we can finish up the other board. So the controller's off, and now we need some MOSFETs. And for the MOSFETs, I actually, like I showed you, was able to find close matches to those, which are on this board right here. And the even better thing is that these MOSFETs are even better than the ones that were on there, because these withstand more current, because they have a lower RDS on. So if we take these and put it onto the other board, it's actually an upgrade. They won't be the same like the ones that are on there, but I think it should be fine, because these are very closely matched N-channel MOSFETs. So I don't think that we're going to have a problem with that. So let's take off these MOSFETs. We need one high side, one more low side MOSFET here. So let's prepare the places of the actual receiving board here. This was the MOSFET that I did not take off. That was the one that was already removed. So let's clean this up. So more than enough solder there. And let's apply some leaded solder to these pins here as well. So let's put this low side MOSFET onto here. This one needs to be on like this. And the high side MOSFET goes onto here like that. So let's heat this up and get these MOSFETs in here for now. There, the high side MOSFET is on. Let's move over to the low side MOSFET right here. And there's the low side MOSFET on. Let's reflow these. Because there's not too much heat, not enough heat in these. Let's reflow this one as well, because they have definitely been working on these ones. Let's just quickly reflow them, just so that I know that these are properly in place. There it is. Oh, one of the caps is blowing up. Oh no. Yep, I thought so. One of the caps has swollen. Did not blow up yet. Let's remove it. Oh, yep. I thought so. That cap has swollen up and I was just able to remove it, and it did not pop. It just released a little bit of its fumes, but that is not a problem. These capacitors are not a problem to replace. Let's also reflow these two then, because it's already, the board is already really hot at that point. So let's reflow them. So this one is also reflown, and that one is reflown. And I think another one of those caps gave out its insides. No, the cap is still fine. Okay. It looks awful, but it's now reflown, so I now know that they're properly in place. We will have to place another capacitor there. The MOSFETs are on. And let's now move over to the ISL controller right here. So let's put leaded solder onto there, so it's easier to get into place. Let's take a little bit off of that middle, that it's not going to overflow. Just like that. Oh, we can take off even more. Like that. Just a little dab onto here. Now I'm fine with that. Let's take the ISL controller. Let me see what orientation we need. pin 1 to the bottom right. So right here. So let's protect the RAM socket again. And let's try to put this on. I probably have to hold the chip. Let's see. No, I don't have to. Okay, it just stands there. So that should be it. Or did the board just bubble up there? I'm not too sure. It might have. Did the board just bubble up? Yeah, the board just popcorned. We might be fine, but it's probably not fine. Ah, that is a shame. The board has been heated up so much before already. So I'm still interested in how this board behaves and if we have a proper signal on these. But yeah, having it popcorn is basically, most of the time, like having a board popcorn is basically the death of it. Because the chip went on really fine there, actually, like without any big problems. So the board cleaned up mostly fine, as you can see right here. I will still have to put that capacitor into place and that capacitor into place. And I might want to replace these ones as well. Because they got exposed to a lot of heat. And I'm pretty sure I have a 20 microfarads in stock. So let me also do that. So now the area is cleaned up. It took quite something to get these holes cleared so that capacitors can go through here. Like this sunk a lot of heat. Like the one that I removed wasn't hard, but the ones that were already soldered, they had like a kind of solder in there that was like in pieces already. Like someone put like burnt, like that solder was burnt in there and stuck. Like that was really hard to remove. I think I can now get capacitors in here again. So this was quite some soldering now. We have now replaced upper and lower MOSFETs. We have now replaced the ISL controller. And I've replaced all 4 of those capacitors that were on here. And I just realized that one capacitor that I took out is actually a 16 volt capacitor. And I put a 6.3 volt capacitor in. And I will need to take that out once more. Good that I've noticed it now before it blew up in my face when it took 12 volts, but still. Oh, let me quickly do that as well. So now everything should be fine. I have replaced 2 MOSFETs. One was broken, one was missing. One upper, one lower. Both were N-channel MOSFETs. Then we replaced the ISL, taking it off of another board. Then, what else did we do? We had 3 capacitors that I've replaced and 1 capacitor that I just had to put back because I desoldered it before. And that should be about it. We need to see that all of the USB is working and the Ethernet. So I want to do that, and we want to boot into Windows. And while all of that is happening, I want to check all of the phases for its PWM signal. So for that I got my oscilloscope out. And we want to see that the PWM phases all look the same, or look similar enough. So, passive power consumption, 100 milliamps. Let's hit then the power button. Let me get my probe first for the PWM, for the oscilloscope. So, let's hit the power button. It turns on. Let's check. Okay, let me adjust my oscilloscope here with its timing. And let me adjust its amplitude also. And there's one phase. There's the next phase. They do have quite some spikes, but all of the phases are there. That looks good. So all phases are running. Let's check the others that we didn't touch. Yep, they look very similar. That is very good. So each phase is present, just like the ones that we've worked on. That is great to see. Okay. So our repair was very successful. I will probably have to take the controller, the ISL, off of here again to put on the other board. And I will have to order some in order to repair this one. But as you can see, it is already working. We are going into Windows. Let's see that. I'm going through each of the USB ports now, but it looks fine. All of them recognize my keyboard so far. For tested, because we saw at that one place that some traces were damaged, but they are fine. Yeah, I was able to test all of the USB ports, so all of those are working. Oh, what a roller coaster. And there's also the actual desktop right now, and the board is working fine. Oh, great. So actually in this repair, we repaired two problems on the 12 volts for the CPU. We repaired one high-side MOSFET that was shorted, where the 12 volts got into the V-core. Then we repaired a short where 12 volts was shorted to ground because of a bad MOSFET driver. Then we replaced bad capacitors. We did some resoldering also because the soldering looked awful. And yeah, that took quite some time. I think that took like 2.5 hours or something, because just of the soldering and trying to find these components somewhere. But now the board is fixed, everything is working on it. I'm very happy for this repair, because Biostar boards are really rare to come by, because they're like ultra budget. Like, this board is probably worth nothing. It's A520 and then it's a Biostar board. Like, this isn't worth anything, but I wanted to do it for the video. I wanted to get a case out here, wanted to see what was wrong with this. And it was also very interesting because this was a previous repair attempt. Like, we could clearly see that the previous repair technician was definitely in the right area, but he really didn't seem to know what he was doing. Like, he was just trying to dig everywhere. Like, even the shorted MOSFET that we had, that MOSFET was also soldered. Like, did he desolder it, check it, and resolder it? Like, I really don't know what happened here exactly. But yeah, the board is working fine now. It's booting up. And one thing that you definitely have to also learn from this, you can start boards with lower phase count. Try to use a lower power CPU when you do that. But as you can see, we were missing 2 complete phases and the board was still powering up. And now with all of the phases in here, we now can see that it works properly. So yeah, all of my tools, as always, are linked in the video description. If you want to get one of these current meters, email me. I have that linked in the video description as well. So, thank you very much for watching. This was Mainboard Medic, and goodbye.